Not going to help you say it. Yeah. Okay. Oh, yeah. They're going to stop and go backwards and go forward. So that's the nice thing about it. Down there on my bike, I just cross points. I was really glad that the around all the way down to the lost side of the road. Oh, the place to hop over is way down on Grote. No, your mic. Well, say you want to turn on the camera too, if that's well, the greatest is it'll be something.
Unless we plug this. It was working. It was working before we started. And then
It totally works.
All right, let's just get started. All right. Well, thanks everyone for coming. My name is Juan Herrera, and today we're broadcasting live via YouTube. I got a couple of folks on the stream right now. I appreciate your patience. We have a little bit of one of the cameras, so thanks for hanging out. So today our guest speaker is Mr. Justin Grote. He is with Digital Services, and he will be presenting PowerShell for fun and profit. So with that said, we'll do a little bit of housekeeping at the end. So take it away. I'm sorry?
Intros first.
Oh,
We usually do that at the end.
no, we should.
At the end? All right.
So, yeah, take it on.
Not a problem.
All right, hello everybody. My name is Justin Grote, a data center solutions architect with Allied Digital. And today I'm just going to kind of provide a case study of what we do at Allied Digital with PowerShell, how we sort of integrated it, and just sort of probably will help provide you guys with some ideas, some inspiration, and whatnot such there. My presentations are generally pretty interactive. I tend to keep the content light, so if you have any questions, these are hands throw up type presentations. If anything you want to know about, I'll happy to answer your question, or I'll let you know. I'll get into that kind of thing. So we'll just get right into it. So we've got a few things here, just a quick overview. I'm just going to go a little bit about my company, show a little bit of our architecture about how we use PowerShell, talk a little bit how you can foster adoption in your different companies, how I found it works best within my company and my company culture, and then go through a couple examples of things that I've done in our environment or we've done as an organization with PowerShell. Just a small example, just a simple exchange I had with a customer, with a coworker who had an issue getting some information out of Azure AD. Another example is with our monitoring system, developing custom monitors for that. I'll talk a little bit more about what Allied Digital does, so you'll get a better context around that. Now, I'll provide a large example, which is the integration between our monitoring platforms and our ticketing system. That's all done in PowerShell. I'll explain that part as well. And at the end, I have a couple interactive videos and stuff through a dialogue, and that'll mostly just be a section where we can talk about things. If you want to know how we do things a certain way, or if you have problems in your organization, you want to know maybe how we did it, if we have an idea, that's what that's going to be. So a little bit about my company. First few slides are going to be dry. We'll get past them real quick. A little bit about Allied Digital. We're a multinational services organization. We provide management monitoring for a large amount of our customers, basically full IT infrastructure services. We try to, for our customers, our targets are customers where IT is not their bread and butter. They are not IT-focused organizations. They are not a Netflix. They are not an Amazon. Where their focus is they have some sort of line of business process. They make mattresses, they make chemicals, they make, they're in real estate. But to them, these are customers that they want their IT to be like their water bill and their power bill and their sewer. They want it to be a utility, and they want to have it maintained, kept up to date, and payable every month out of the OpEx. So that's where we specialize. That's where we strive. We do other things, the professional services parts, the other aspects like software development teams. We do end user support, but our bread and butter is sort of that core, IT infrastructure transformation is what our executives like to say. So just a couple quick stats here. It's just we have $200 million in revenue in 2015, and that's gone up about 20% the year after that. Was a really good year for us, and then this year, growth slows. So we're at about 10, 15, but we're still growing pretty well in that regard. 10 out of the 100 Fortune clients use us. Our workforce, we got about 3,500 people around the world, and we serve about 600 clients in 90 countries. And those are just the clients that are above a certain minimum with certain things. And those are also just our direct clients. We have a much larger presence with other companies. Our services are white labeled to larger companies that do, anybody maybe a Cisco partner or a Microsoft partner, they want to sell the box, but they don't want to do the ongoing services and support, and so they white label our services. So here's just a kind of overview of our business as well. Again, this is just a quick thing. We have things you guys will care most about is like the data center operations. We support over 250,000 servers, 72 petabytes of storage, network operations, 100,000 network elements, 450 circuits. That's actually 450 circuit providers. They misspoke that. And we have thousands of circuits that get managed, and that's in terms of we do the whole last step. We do everything from when the circuit gets purchased to maintaining the circuit to tearing it down to doing all those. Customer doesn't have to worry about it. and change reconciliations. We do over 45,000 change activities a year. And the point of all this is not for marketing. It's mostly just to show you sort of the scale that we're operating at, so that I can give you, so when you see some of these things, you can get an idea of, the kind of problems they're solving. So Agile Digital, this is sort of an overview of the different components as far as where we use PowerShell indirectly. So at the very base is our monitoring platforms. We use a bunch of different monitoring platforms, some legacy, some are ones, but our goal is that they support certain point solutions. And then our primary monitoring platform is PRTG. We license that, we're one of their largest customers, and we scale that out in our data centers in such a way because we've just found it very powerful, very flexible. It doesn't use a database, it uses simple flat files for everything. I mean, the configuration is just one big JSON file, and that lends itself to the type of business that we want to be. It lends itself to being able to take things, snapshot them, do kind of DevOps-y type things to it, and really allow us to scale that out, really quickly provision it on a per customer basis. And the licensing works really well for us. It's very inexpensive the way that we implement it. On our individual customer sites, we deploy client probe. That is just literally a Windows virtual machine. That virtual machine can exist. We either deploy it on top of an appliance for the customers that want a box. Otherwise, we just give them the URL to download it. They download it. It phones home, connects to a secure system, does all that, and then everything else I'm going to show you funnels in through that. Makes it easy for our customers. They can access and control it however they want, so they can set up their firewall so it only sees certain things and not sees other things. They can control it however they want, and then if something goes wrong, they don't trust us. We like to have our operation built on trust. So, when customers give us the keys to the kingdom, we want them to know that they can just shut down that probe and we no longer have access. A big portion of our environment is built out on Microsoft Azure these days. And in the past, we've utilized several data centers. We were moving forward with a bit of our modernization of some of our core infrastructure. And for a lot of business reasons, not the least of which that we are a Microsoft Gold partner and we get a lot of this for free, we decided to build out a lot of it on Azure. There's a lot of the stuff you could do just fine on AWS and such. The Azure Functions is a little more specific to Azure, but a lot of the architecture I'll show you will work anywhere. Azure Functions PowerShell is an aspect that we use. If you're not familiar with Azure Functions, if you're familiar with AWS Lambda, it's very similar. Basically, it uses a term which I absolutely hate called serverless computing, because that means I'm out of a job in 10 years. But no, it's, the idea behind serverless computing is I like to think of it as server worry-free computing. You don't have to worry about the server. You don't have to worry about the underlying OS. You just write your code, and the system figures it out, runs it for you, and bills you on a very, very granular basis. Gigabits per second, they say. So you don't have to keep a server running that you never use. You don't have to keep a container running that you even use. So this is like the even further level of getting it just distilled down to that bare code. I'll talk a little bit more about how that works very briefly. And if you guys want later, I can do a really deep dive on it. We also utilize Visual Studio Team Services, which if you're familiar with GitHub, this is basically Microsoft's equivalent of GitHub. In fact, it uses Git on the back end, which is at least the way that we use it. We use Git on the back end. A lot of the projects that we've developed internally, we've also open sourced on GitHub for people to use. A lot of modules out there. If you've ever used the Sharp SNMP module, I wrote that. So if you're going to use SNMP and PowerShell, there's only 2 modules and one was broken. So if you look on the PowerShell gallery, if you look for Sharp SNMP, that module is a very simple one to do SNMP with PowerShell. And again, that's a topic for another time, but I can go over how I did that, where basically I just found a .NET library that did the trick and wrote a wrapper around it. And now it powers like hundreds of thousands of SNMP transactions a day in our infrastructure. Azure Automation is another piece that we use. We don't use this one as much for the scripting piece. We used to until Azure Functions PowerShell came along, and so we migrated most of our stuff to that for reasons I'll explain in a bit. But Azure Automation, the main portion we use here is DSC, or Desired State Configuration. How many of you guys are familiar with Desired State Configuration? Okay. Long story short, Desired State Configuration is just group policy only in PowerShell and be able to do it anywhere. The way that we use it is, again, for those probes that you see down here. We use it to control all of our probes so that when a probe goes out to a customer, it is literally pretty much a bare install of 2012 R2. In fact, we support our customers if they want to use their virtual machine image. We use a combination of DSC and Pester to basically lay down everything that's our stuff, lay down all our tools, lay down all our software, see where that the customer has changed. It takes a snapshot of the whole virtual machine, finds the registry differences and such, and It gives us a pretty simple snapshot to get an idea of, oh, they installed this software, and oh, they installed this. And that's mostly just so that we don't see anything weird going on. No hijacking things, that kind of thing. But then it lays down all our monitoring software, lays down all our access, lays down all the configuration and customization that we want, and then does all checks to make sure that it can do connectivity back to our system. Basically, as long as it passes all of our tests, then we're good for that probe to be a production probe for monitoring and managing the customer's environment. All of our reporting, for the most part, is built on Power BI. I'll talk a little bit about that in a bit, but Power BI is basically, if you've ever used Power Query in Excel, Power BI is basically that being split out into its own product. And the really nice thing about it is that they built this thing called the Power BI service, which will do all the number crunching and such in Azure. And Power BI is sort of what if analysis. Like when you have an Excel spreadsheet and you have a pivot table, you can kind of do stuff with that. But Power BI is really powerful. Where, like an example I usually use is our ticketing system. We have our monthly reports that go to our customers that they're able to access, and it shows them their ticketing. And if they want to know, have you ever seen like that one bar in your reports? And you're like, what does that blue bar consist of? Normally it's like, oh, well, we'll get back to you and we'll tell you. We'll come back to you with a more detailed report. No, Power reports, you just click it. It brings up exactly what's in there. And then you can drill into it and see it by category. If you haven't seen Power BI, look at a couple demos of it. It's really powerful stuff. It's really easy to use and has a full PowerShell interface. So all of our Power BI reports get generated and teared down using Power BI PowerShell module. Yeah, it used to be a process that we had teams generating manual Excels. We had a team of like 50 guys in India, and that's all they did. And now it's almost all automated. That we were able to repurpose those guys for something else. It's just all done in Azure Automation. Excuse me, in Power BI and Azure Functions PowerShell. And Microsoft Teams is sort of our core point of collaboration. Every single customer that signs up with us, we now build them a Microsoft team. Microsoft Teams is basically just, if you're familiar with Slack, it's Microsoft's way of doing Slack effectively. I mean, essentially, I would say effectively, but but it works for us. And it all runs SharePoint on the back end. It's directly integrated with Exchange. It has a lot of tie-ins that just work. We were already doing SharePoint sites, so it just made a very simple, natural transition. So every customer gets an MS Teams site. All the documents regarding our services, all the reports get linked through that portal. If they use the chat in there, it's directly linked with their account manager. And so, provides access. And again, the spin up of those teams, when a customer gets onboarded, once they get signed, the team just runs one PowerShell script that fans out and creates all this stuff, one of which is just one of those Microsoft teams, just like that. Microsoft supports over 500,000 site collections, basically 500,000 Microsoft teams per tenant. So it scales just as we need it to. And then we still have all our physical data centers. We have one in Irvine, California, run by Cyxtera, where we still have some components running. And in there, we have a few virtual machines that operate as what are called hybrid runbook workers. This is a piece in Azure Automation. Previous meeting, we had a guy here talking about Azure Automation. So here's an example of it actually being used. All this does is simply, there are computers on site that you can manage and control your scripts, and what they call them runbooks in Azure Automation, but they're scripts, they're PowerShell scripts. And when you want to run something on site, it basically has a encrypted tunnel that goes up, and you can coordinate it out there so that when you kick it off, it runs locally and returns the result. So you can have it all centrally coordinated so that we have a very simple centralized thing. It all uses all our powerful auditing policies, and we know how every script ran, its status, all that reporting comes in through the Azure Automation, look at it through Insight Analytics, and basically gives us a great view of every single script running in our environment. To the point where we have DSCs that look for PowerShell scheduled tasks and alert on them, because nobody is supposed to use a PowerShell scheduled task directly on any of our production systems, because we want all in Azure Automation, or we want it as a PowerShell scheduled job. Another data center, my favorite data center, the Switch Data Center in Vegas. This place is awesome. Check out the videos on it sometime. Great, they got great videos. Plus, every time you got to change out a server, which isn't the worst thing, but after you've been to Vegas like 12 times in a year, it gets old real fast. Again, hybrid runworks workers there. And then finally, we have our India data centers. I just included this picture to make poke fun at my India workers. It's a good data center, though. It's in Pune. And a lot of our NOC team is there who do a lot of the management. Yeah. So some quick facts about how we do PowerShell. Big thing was that about a year ago, we just standardized everything on PowerShell 5.1. And the reasons for that are a couple. We didn't standardize that PowerShell 5.1 had to be installed everywhere. It's a big difference, because We just standardized that all of our scripts had to be written where the, basically right there, they had to have require version 5 at the top. You had to write them so that they required version 5. And the reason for that are a couple here, but the big thing here is that the PowerShell gallery was the biggest thing. Now that the PowerShell gallery and the PowerShell get module was available, and it was very easy to natively integrate those. If you're familiar with Perl, things like CPAN or the Ruby gem library or NuGet, these are all basically ways for, for different things, .NET, Perl, etc. These are libraries where you can download and share software. And so we found that the PowerShell gallery had finally reached a maturity point, as well as the recommitment from Microsoft to really make that industrial scale, to the point where now VMware, their primary place you get the VMware commandlets is on the PowerShell gallery now. So that is being able to have that access was very important to us, because a big problem we had was when we wrote our modules, we previously required they had to be monolithic. So if you referenced another module, you had to include it in the module in the includes folder. And we used submodules and stuff to make that work, but it was a pain to handle. And so once we finally decided to change our standards, where we said, all you have to do is reference the modules with requires. Because then when we pull down the modules using install module, if my module that I've made requires my Sharp SNMP module, it will just fetch it. And if it's available, it's there. So now the concern becomes, do you get into DLL hell with that, where this particular version is not available? No, because the way that the PowerShell gallery was built, everything is saved regardless. Nothing is ever deleted from the PowerShell gallery. Remember that if you ever upload a module to the PowerShell gallery, it will never be deleted. So be very careful you scrub all your API keys and everything out of it. You can hide it. So you can hide it, but if somebody queries for that very specific module version, it will always be available. And again, that comes down to that thing. Is that it works very similar to, like, that big fat Windows directory they have, the WinSXS directory. That's the whole point of that thing. That thing is to keep every version of every DLL that ever gets installed on that computer. So if any program ever references it, it's available. This stuff is less important these days with things like PowerShell Core and the new PowerShell standard coding platform, which I'm not going to talk about today, but that can be a lesson for another day. But for the most part, that was a big reason why we standardized on PowerShell 5.1. And then another big thing was classes finally came along, and they were in a good state, and engineering just desired state configuration nodes, basically the recipes that you use for desired state configuration. It's like writing a group policy. Writing it as a script or a script module is a pain. It's not great. Writing it as a class, once you learn how classes work, is really elegant. And the most important thing being is you can write a Dsc module, but use it in other things because it's just a class. You can instantiate that class and run the test. Because every DSC class has 3 things in order for it to work. That's have a test to see, is this thing on the computer, a get to get the information about it, and a set to set it to its desired state. That's how group policy works in a nutshell. That's how DSC works in a nutshell. Key one there being test. Well, we do a lot of tests, we do a lot of monitoring. Man, it would be great if we didn't have to write a DSC for the times we're remediating things and then have to copy it or separate it or have it in some other format. We can then use it in our automated testing solutions. What would be great if we just write a class and instantiate that class in our testing, but have the one unified code base for both that and the DSC part of our services. That's a big reason we standardize on that too. A small one, but was very useful to us, is the using keyword. That was added as part of the classes. But basically what that lets you do is if you're working with .NET library, we do a lot because we interface with a lot of different customers. We interface with everything from EMC SANS to NetApp. And if they don't have a REST API, they might have a C# API. Some do. And so then you could utilize that. And the using keyword just makes it so that rather than every time you instantiate a class having to say, if you're familiar with C#, you know how this works. Or if you have to say system.net.web API, and instead of having to reference that whole thing, you can just reference it once at the top of the namespace. You can just say using namespace system.net.http. And now every time you do those little brackets for things like, like hash tables and stuff, you don't have to write the whole thing out. You just do the small part. So that makes our scripts a lot easier to read, a lot more elegant. It's a small reason, but it was part of our decisions. But the big things were those 2 things. It's the PowerShell gallery, especially running our own internal PowerShell galleries, so all of our modules, everything that we do. Every computer that's in our organization is preset to have both the PowerShell gallery, but our gallery overrides it. And in certain systems, the public PowerShell gallery is not. It's just to avoid, anybody accidentally downloading something they should. And PowerShell galleries are easy to run. I can do that as a separate thing, but you can literally just use a file share. Like you can make an Azure file share and just host it out there, or you can make a file share on your local computer. You just use a directory, and you can, as you just register that directory, you can do publish module, you can do git module, find module, install module, and it'll all work. It's really powerful stuff. We use a bit fancier version of the gallery for obvious reasons, but it allows us to have a central repository for everything that our team does. And a big thing on this too was that we got to the point with 5.1 where, yeah, we still manage a lot of 2003 systems, 2008 systems, but all of our probes we could standardize on at least 2012 R2. We were able to get them past 2008 R2 to 2012 R2, and 2008 R2 was fine, but because of all our probes and because they're all managed by DSC, we were able to get 5.1 on all of them. So with our probes, when they're doing the monitoring, just because a computer out there doesn't have PowerShell 5 on it, doesn't mean that we can't use remoting and implicit remoting to run those level commands on those, so that our scripts are written in such a way that they generally run from the probe and go out and fetch information. If they can get it through WMINS, it'd be great. If we have to go to that computer and run the command, we use PowerShell remoting. But if the thing's only got version 2 or version 3 installed, we don't want to have to hassle our customer. If a customer has a server out there that's only got version 2 on it, they obviously don't care that much about changing that thing. And so it's hard, because upgrading is a reboot condition. It's really hard to convince customers to be like, hey, do you mind re your production infrastructure while we put this thing on that's not going to matter to you? So instead of implicit remoting, we go out, we fetch those commands from the computer, import them into the local script, and then they can use them, and then it just implicitly gets the information. But all of our scripts, even though they're all written in 5.1 and use 5.1 verbiage, can still interact with computers that are 2 and 3. They can't run directly on those computers, but we engineered it so that they don't. So those are all reasons why we made the, I would say, somewhat brave stance to make everybody use 5.1. All our developers have to have 5.1 on their computers. It's not really that big of a deal because it's really pretty easy to deploy. And then as far as PowerShell core, we do use it to some extent, but there are some limitations with it for what we do that we don't use it extensively. Big thing is DSC is not available yet. They're promising that here pretty soon, and that'll be great. Another big thing is a lot of the Azure commandlets and such don't support it yet. We do use it in certain areas where we need high performance. We have certain scripts that just basics, and all of our new modules that we use, they all have to be both compatible. So there's this thing called the PowerShell standard that's available now. That if you write .NET-based commandlets, we mostly write script-based commandlets where everything just is a PowerShell script. But every once in a while we have to write one in C#. And I am not a programmer. I hate working in C#. It drives me crazy. So if I can write in PowerShell, I do. But for those ones that we have to compile that way, you can use the PowerShell standard where if you compile your module, it will work in both Windows and PowerShell core with the one module. You don't have to make 2 separate modules. The one module will work everywhere. And so a couple things about that finally is just, it really helps us. PowerShell Linux is definitely the forward. I mean, we have a lot of advantages to it. It's just the ecosystem has to catch up a little bit more before we can release it. The big thing that will make that happen is when Azure Cloud Shell switches over to Linux, which is going to happen here pretty soon. That once they have that, then because once they do that, they'll have the Azure modules ready for PowerShell core as well. And basically, that if you've ever used Azure Cloud Shell, if you ever logged into Azure, there's a little command prompt up at the top. You can click it, choose PowerShell, and it basically builds a virtual machine and runs it. They're going to make that a lot more efficient here very soon. So don't get too invested in that as it is if you're doing PowerShell, because it's going to change very soon. It's going to be really good. I've already seen a lot of the code. It's all open source, so you can download the code and run it. It's good stuff. Another big thing we do is continuous deployment. Even though we are just an infrastructure shop, and even though we just are effectively, we're a revenue generating organization, we found that adopting those sort of DevOps-y type things, and I hate that word too, but adopting those sort of aspects of continuously releasing, not getting hung up on getting really tied to releases, except for when we need long-term support builds, making sure our company can move fast and quickly as we roll out these new modules and such, has worked really well for us. So again, I mentioned earlier we use Visual Studio Team Services, but it's all Git on the back end. And so we use Git branching and all that kind of stuff. The methodology we use is Git flow. If you ever looked at this, basically in short, what Git flow is just a way of using Git. It's just a way of organizing Git that you can teach everybody. And the long summary is basically you have a master branch, and you guys all familiar with Git and source control and that kind of thing? If not, it's basically just a way to like have different versions and backups and a way to keep track of code and have multiple people work together on stuff rather than, saving a notepad file and then emailing it back and forth, and then somebody changed something and then you don't know who changed whatever. And if you both want to work on two separate things, you have to be careful you don't run into each other. There's a long-standing program. If you're a scripter, you'll run into that. I have coworkers who are working on scripts, we're both working on the same thing. Or we need to know, hey, this is the stable thing. We're going to try this thing, and if that doesn't work, how do we get to the old thing? And so all of that we just found using the Git flow methodology with Git and controlling all our scripts in that sort of process works really well. And we use it very similar, like you would if you've worked on any GitHub project. Pretty straightforward. We write our scripts. We generally require everything to be modules, although we do have a section for scripts. And those basically have to be controller scripts. If it's going to be a tool, it has to be in a module. But if it's going to be like a controller script, it's going to be like, well, we take these things together to do this whole process. That can be just a script because in the PowerShell gallery, you can do scripts in addition to modules. And you just do install script as opposed to install module. And those can be handy for a lot of things. So with what we do there, we have our master branch and we have our develop branch. And then every time someone builds something new in our code base, they make a fork of it. And they make feature dash or bug fix dash. And they say, I'm going to make this new module, I'm going to make that. They work on it, and then it gets merged back into development. Development immediately, if it's part of our Azure PowerShell Functions set, it goes immediately there. We require them all to include pester tests. We have our own pester tests that test every module to make sure they meet some of our basic things, like that requires version 5. That's one of our very first pester tests. If it doesn't have that in there, fails it, sends it back to them, says, fix this. And none of us even see that. It just does it. And they get the email. They got to fix it. And then once they pass it, then it gets generated as a pull request. We can review it. And then if we pull request it in, then it goes into development. And development, every time something commits to development, tears down the whole development environment, rebuilds it. And then we use the development and master, we use what's called A/B slotting. And this is something that's is a pain in the ass when you have a lot of servers, when you have a lot of physical servers. But if you're using Azure Functions PowerShell, it's all just code. And I'll show that to you, where we can build a whole slot. I can do a separate thing where I'll show you, I can build you an entire multi-redundant A/B failover slot environment manually, not even doing it with scripts, in about 10 minutes. And so what happens is that we have the two systems, our test systems, so every system is -test. That's for everything that we write in Azure Functions PowerShell, which I'll show you some of that here in a minute. And what happens is that once it gets committed, it shows up there, and then it's 24 hours between when that test one cuts over to master, and then the master gets teared down and it becomes a new development. And so what that allows us to do is every time a commit happens, it shows up in our test environment, and everything, all of our tickets, all of our systems that generate tickets, they always submit to both systems at the same time. So the secondary system is always getting them, always seeing them, and has to pass all the pester tests. We have pester infrastructure tests to make sure all that stuff works if they're changing something about the infrastructure. And then if it all passes and it's good and it stays that way for 24 hours, then we don't say, okay, this is good, tear it down and then make that master. That environment is already warmed up, so it just becomes master. And it cuts everything over, and then the old system gets torn down and does it. I don't know how any of this works in Azure Functions PowerShell except for what I've read in the source code, because I don't do any of it. I didn't design any of it. This all just works natively in Azure Functions. And again, I'll show some of that, but it's really cool stuff. So again, with our repositories, we maintain our own 2 internal repositories, and we kind of follow the Microsoft methodology of this. We have general availability and preview, just to do better. They have general availability and preview, and that's very similar to that, where the repositories, anything that goes into before it hits development, if it's in development, it shows up in the preview. And until it gets committed to master, it doesn't show up in GA. But anytime anybody commits something to development, if they make a module, it goes in, does all the pester tests, does, make sure it works, runs the commands, imports it, does all that in an app bearer instance. If it looks good, then it compiles it, makes it a zip, sends it up to our gallery, and you go to the preview, and now anybody in the company can download that module and run it, and test it, and use it, and integrate it into whatever they're working on. But they can't use it for production. It won't show up in production. If this production and whatever they're working on gets committed to master, then it shows up in production. So how do you get this stuff to work with, an organization that's not big on PowerShell? I've never heard of this. I've never done any of this kind of stuff. So I kind of have a general 3-step process that I use. Main thing is leading by example. And I'll show an example. That's my first example that I'll show when we get here in a second. Big thing is that when you get started, What are the problems that you solve every day that you're doing 5, 10 times a week? You're doing the same thing over and over again. Can you use PowerShell to solve that thing? You know, if you can, give it a shot. And if you can, then solve it, and then you can show that to somebody else. And if you don't have something like that, if you're so hotshot that you've done everything, you probably got a coworker who's got this report that they have to generate. They have to click these 5 different places and go find it. Whereas and then they have to put it into Excel thing and then sort and do all that kind of stuff. Well, if you can figure out a way to automate that for them with PowerShell, you know, you can make a real good friend, and you can have a tit for tat. Hey, if I do this for you, can you take care of this for me? Another thing is that once you have something that's like, hey, this is really helpful, maybe somebody else needs it, if you can build it as a reusable tool where it's like, okay, well, this is a great way to take a CSV and process it into an Excel file, but if it was written in such a way that I can take any CSV, not just this very specific one this guy wrote, and export it to them, then now you have something that the whole business could use, and the world at large, if you choose to release it as open source. So once you have that process down and you've gotten some practice, you're getting pretty good at writing scripts, you're getting your process down, and you're generally contributing value to the environment, show that to your boss. Document everything that you do. You know, to me, I'm a big CYA guy. Everything I do, every time I have a meeting, every single time I have a meeting, everybody knows that within 5 minutes of that meeting, there's going to be an email from me summarizing what we did, what I agreed to, you know, and if nobody challenges it, then that's where it belongs. So if it ever comes back and somebody says, hey, Justin, where are we at on this? I didn't agree to do that. It's like, hey, show me in here where you told me that I didn't agree to do it. This is what I said I agreed on. You know, otherwise, audio, unless it was a meeting was recorded, everything else is hearsay. So you can take that same and apply it. You know, when I first got started with this, a great example I like to do with this is I was one of the very first people in our company to get an executive corporate credit card back after they got taken away because the sales guys had a little too much fun with them a couple of years ago. And how did I do that? Well, I had it before the CTO had that. And the way I did that was simply whenever I made us itemize all our stuff and scan the receipts and everything. I basically just documented all the time that I took to do that process. I wrote it all down, and I took the amount of dollar time of my salary it was. And every time I sent that email, every week when I submitted my expenses, there was a running total at the bottom. That was, this is how much this process has cost me. And after about 6 months, finally the finance guy said, just give that guy a call. And then the CTO found out one day, and he was like, how did you get, and I explained it to him. And after that, like, everybody got him because he's got the weight. But that's how I kind of, you know. But again, I have a huge belief that if you can't measure it, you can't improve it. And so measuring things, and PowerShell is a great tool to measure damn near anything. You know, we're in the business of measuring things and monitoring and improving. And so you can apply that to not just a large company. You can apply that to, again, something as simple as your expenses and provide tangible data to somebody that enacts change. So that's a small example of a personal thing. Well, what if you have an environment that, or a process like the reporting that I talked about, where we had a team of guys generating Excels, you know, in your environment, maybe you have a fax machine somewhere where something gets scanned to fax, sent over, and then done back up. It's like, well, why don't we just email that? The answer is always, well, we've just always done it that way. There's usually not a real good reason. It's just, well, this is just what we've always done. So, why not change it? Well, we know how to do this. We don't want to change it. And that's what their bosses say. It's like, they know how to do that. They don't need to change it. But you can tell them, look, I've done the math. If you change this, you will save, you know, $700 a month just not doing this one thing. And it will cost me, you know, it will cost $500 to implement it once. And you've already hit your ROI in the first month. To a business owner, that's a big deal. And even if you're a cost-based, you know, we're a revenue-generating IT organization. We have costs too. We do everything dirt cheap, as I've talked about. Like, we are cheap bastards, because even though we're a revenue-generating organization, margins matter. So even if we make, you know, X amount of dollars, if all of that's in cost, who cares? We all wasted our time because we broke even. So margins, we're still about keeping our costs down because we want to keep our margins up. But if you're in a you know, if you're in a cost-based IT organization, which I've been in, or, you know, I support a lot of cost-based IT organizations, there's still areas where, you know, reducing waste, reducing user time, reducing systems that are unnecessary. Especially if you see areas where there's big stepwise distances, if you can reduce that cost, and again, show tangible, not just say, we need to do this because technically X, Y, Z, because it'll be X amount faster. If you can translate that to, well, if it's X amount faster, it costs us Y amount less in money when we do this, you can take that and translate it to the business. That's how you really get these projects adopted. And that's how PowerShell became the process of doing this versus Ruby or Python or et cetera, because I like PowerShell. I thought it worked. I made these cases. These cases get to the CIO, they get to the CTO, they see what they're doing. And slowly but surely, now everybody's getting PowerShell training in the company. And now everybody's standardizing on using it for these activities. We still have the C# guys and everybody do, in the job, we have a huge Java contingent of guys who do everything, but they really don't like it when I come in. And they've written this thing that took them like 4 weeks, and it's 2,000 lines of code, and I do it in a one-liner. Oh man, they hate that. They hate that so much. And I try to be very respectful because again, there's no need to burn bridges. There's no need to for the sake of ego. But man, do they hate that. But it also is like, oh, I actually can see how this can help us. And so as that goes forward again, I always like to start from the bottom up at the very beginning, but if you actually want to make substantial change, you got to go from the top down. You got to get executive support. And finally, you have to practice what you preach. It's a garbage in, garbage out world. If you write crappy code that's undocumented, that's all shorthands as opposed to sort of more PowerShell-y standard, then nobody's going to be able to read that. Nobody's going to be able to maintain it. Nobody's going to want to follow in those footsteps. And you become the guy who's indispensable because you're the one who knows how that stuff works, but you're also stuck in that position. So if that's what you want, great. But me, I always like I get bored of stuff 2 months after I've started it. I'll always want to do a new thing. So I try to develop that, and I like to help out my coworkers. If I can enable them to do what they need to do, it's going to make a big difference. I believe in test-driven development, and when I say test-driven development, I do not mean writing the test first. I know this is a huge fight that I always have with people. Everybody says, programmers at large love this idea of BDD, where you write the test first, and then you write the code to pass the tests. In some areas, I agree with that. In terms of if you are working with another organization, you need to define what your APIs are going to be. You need to define how you're going to interact. That is a great place to do test-driven development. However, if you're like me, where you just need to figure out how to interact with an API, you don't know what you're going to get back most of the time. Like if I'm logging into an old EMC system, I'm running Navis CLI, and I need to parse the text. I don't know what the text is going to look like the first time. I don't know how to write that test, and I might do something different that changes it. I have to dive into it, run the commands first, see what I get back, and then I can be, okay, this is the best way to do this, and now I can write my test to make sure that this doesn't break, make sure that it passes. But having tests, using Pester on all your scripts, or whatever you want. Pester's great, but you can use whatever testing methodology you want. I just think Pester's super easy to use. Having something that every time, again, we have our commits, having something where you don't have to manually test it, you don't have to split up a dev environment, it makes your life easier. Like I'll show you, when you can just hit commit, and in my case, I just hit Control-Shift-Enter in my VS Code, and that kicks off the whole process. It's uploaded, goes into the repository, starts the processes, starts up a virtual machine. A lot of this doesn't take that long to set up. It's not like I had to develop the whole process of continuous deployment. Stand on the shoulders of giants and have other people do that for you. Just utilize the stuff that's already been built and make your life easier. I don't have to worry that what I committed didn't work unless it comes back to me saying my tests failed. They have to run good tests, of course, but that's really not that bad. And I think what we try to emphasize too is keep PowerShell. I believe in Jeffrey Stover's PowerShell promise, which is if you take the time to invest in learning how to do PowerShell, I promise I'll do everything in my power to make sure that you don't have to learn it again. The Azure team did not follow that promise. If you've ever used the Azure commandlets, they just made it basically mirror their REST APIs, and it's awful. The VMware PowerShell team, they know their stuff. Those guys wrote commandlets that are PowerShell-y. They support the pipeline. The parameters match. What you would normally get. Just when you write things, just think about if it was somebody who had only used PowerShell for a little bit, and they've only used the base things. They know if they do get WMI object, dash computer name gets them to this thing. So if I'm going to write a PowerShell module, like I wrote a PowerShell module for Traverse to interact with this API, if you do connect Traverse BDE, the option, I have a bunch of aliases there to allow things, but computer name is one of the aliases. If you do computer names, that's what you know how to do, it'll work. I believe in that a lot. I believe in making sure everything supports the pipeline. I believe in a lot of intelligent casting. Or use PowerShell, use things like validate by property name, where if they pass an object that has computer name as a property, then that should match to your computer name property. If they just want to pipe that, not have to figure it out, not have to first extract it out, go forward to pull it out, and then run your command, if they can just pipe the object to it and it'll quote unquote figure it out based on whatever type the object is or whatever, which is not that hard to do anymore with the validate parameters, commandlet binding, then again, your tool is going to be easier to use, people are going to be able to use it, and it's it's going to have wider adoption and better use. If you're not too careful, this is what you end up sounding like in your company if you get a little too aggressive with this. So just also remember PowerShell is just a tool, just like anything else. The guys who do C#, the guys who do Java, the guys who do Ruby, the guys who do Python, the guys who do Python with network automation, like I can do some of that in PowerShell. I can do a really nice PowerShell SSH module, but they've already got processes and they got Ansibles and everything to do that. If it's working and it's good, some of it we can adapt and it helps, like from a monitoring perspective, but otherwise, again, why reinvent the wheel? In the end, it's about making the company better, and PowerShell is just a tool, as well as a tool for making tools. If you just go around, I love this picture because it's like this. But I feel like sometimes I go into the place and like I find my coworkers look at me like this. It's like, how are we going to solve this problem? It's like don't say it, don't say it. All right, so coming to that, here's a small example. Here's an email that came in not too long ago. They were having an issue with a customer where they had a customer that had a lot of ex-employees. This was this large company that manages basically all, they have this huge network of hospices all around the country. And they manage out of Chicago. They use Office 365, they use Azure, and developed the whole sync for them. But one thing is that they had a situation where they had this huge amount of ex-employees. They had about 36,000 employee objects in their directory, and 20,000 of them were ex-employees. But they never deleted anybody, they just disabled and moved them to ex-employees OU, and they were syncing that out to Azure AD. So they were like, okay, we got to. So they took them all out, but they needed to make sure that when they ran the Azure AD sync, that didn't delete everybody, that they did it right. So they did it, but then when they tested, if you ever used Azure AD is just Microsoft Identity Manager in the background. It was really weird the first time I pulled up the underlying console. I had done Microsoft Identity Manager like 7 years before that, and it's the exact same. I was like, oh, they just use the same code. Okay, great. I know how this works. Like the girl in Jurassic Park, Unix system, I know this. And so to bring that tangent around, which you notice I go on tangents a lot, they had to delete all these things. And so as a result, when it came back, they just got these source IDs, which are basically these anchor IDs that anchor a user to Azure. And they were like, okay, well, here's the list of the source IDs. And the customer came back being like, I don't know what these are. Tell me what users they are. And they came back to me, and I told them, well, here's a couple places you can look. I sent them an article. They came back, well, we can't figure it out. We don't know how to solve this. Now we can move forward. We tried this, and it failed. And this happens in a lot of companies where people just stop, and not get creative. So, how do we solve that? So here's what I did. Responded back, basically gave them, this was a case where these guys needed this done quickly. So this was given a manifest here. Was basically I did it, and the key thing here is I showed it, what it worked, how it did, and you'll notice, even though it's just a fairly simple script, wrote all this in VS Code. If you cut and paste from VS Code when you're formatting, I don't know if you know that is super nice for email. I just cut and paste this from VS Code. And this is not text. In the email, you can highlight it, cut and paste it. But you notice, I did everything. I had to require this particular customer needed because it had to run on the Dsc system, and the Dsc system is still 2013. And so, but I included a synopsis. I included examples of how it worked, and before I even got to the code of it. So the guys that got that, they didn't have it. They're not guys get, oh, okay, this is how it works. But then they can take that and reuse it. Oh, well, here's a way to convert this thing to an immutable ID. Now I can use this function, convert from this DN to an immutable ID. Maybe I can use that for other things. Like, what if I want to see what's just changing in Active Directory every day, and I wanted to get what users were coming at? Well, now they got a tool to do it. They just have to feed different data into it. So there's an example. Build a simple solution. So that's that. Here's another way that I use sometimes teach it. Here's a case where we had a engineer who had a task from a customer they wanted all of their servers. They had all these branch offices. In the branch offices, they have main controllers, file servers, and print servers. They simply said they wanted all unnecessary servers turned off on those systems. And they had bought one of our super premium contracts where we do basically everything for them. Where it's all just TNM, whatever they want. because they're willing to pay up to a certain budget, and then we renegotiate if we hit that. But anything beyond that, it's a la carte. A lot of our packages are like, okay, we maintain the business, but we don't do net new stuff, and we do certain reporting and such. But these guys got the premium package. That's what they wanted. So these guys came back and they were like, well, how do we do that? How do we define what something is? Well, these are guys that I know a little bit of PowerShell, and I know that they have the ability to do it. And I also know that their boss is pushing for them to push it. So instead of give them the direct script, I get a little bit more of a blueprint sort of outline. Here in every branch, we got these. Sorry for those on the webcast. I'm talking away from the mic. I gave an overview of what do you know about it? In every branch, these things. Well, for each type of thing, you know that there's certain services that have to work on, like Active Directory, print service, the print spooler, file service, the server service. So how about if you do this? How about you first use Get Data Shady Computer, find all the branch systems by looking at them based on their Active Directory site and service. Then how about you get a Microsoft expert, don't guess this yourself, get one of the Microsoft experts on our team and have them tell you what services are the minimum required for this role. And we already have tools that do a bunch of this stuff, but I want these guys to figure it out themselves. And so get those tools and make a template, get an idea of that, and then use PowerShell filters, produce a list of services that are running on all those servers but aren't part of the approved list. In most cases, that's do it all, do a big Git service, get it from every single system, throw that all in a big Excel or a CSV or a JSON or whatever, or CLI or whatever you want, some format, and then filter it. Say, take all the ones that aren't that approved list, where not this and not this and not this. And then you get back this big old list. Okay, well, I can take that list to the customer, review it, and say, take it back to the Microsoft expert and say, okay, here's these services. That's actually needed because they do a special thing. For everything else, take that to the customer and say, okay, here's what you want. These are all the unnecessary services. You review this, and if it's okay, then take that and feed it in, have it go through, stop the services, and send a manual. But as a result of this, those guys did write the script. And I helped them out a little bit more to massage it to make it a little more efficient, but for the most part, they figured it out. And in the future, they don't need to bother me about it. And so now I made my organization better because they previously would have been at a stopping point here. They would have gone and bought like a 10-grand commercial solution to go do it, which was very de rigueur in our company. It was like, oh, we need to solve this problem. Yeah, this company has a point solution for 50 grand. That'll do it. It's like, well, I got a PowerShell script about this long that'll do it. So here's a bit more medium-sized example. In our environment, we use PRTG as sort of a primary monitoring system. One of the things we really like about PRTG is it allows for these custom sensors where if we write a script, it can deploy out to all of our probes. And if we attach that sensor to a particular device or set up a definition to detect it, we can detect based on model number, detect on the serial number. If it has a particular SNMP OID, we know, okay, this thing's a switch, or we know, okay, this thing's a thing. So here's an example for Exchange, Microsoft Exchange. How many of you guys have you worked with Microsoft Exchange 2013 or later? So are you familiar with managed availability? You know what that is? Managed availability is basically, in Exchange, managed availability is a service that was added in 2013 that is literally a monitoring system for Exchange built into Exchange. It goes through and it checks everything. It will do synthetic transactions. It will query OA and make sure it works. It will check queues. It will make sure that the DAG is on best practices. If you've ever had an Exchange 2013 server blue screen out of nowhere and you have no idea why, it's probably because the managed availability check failed. It was considered a high availability impacting thing. And if it was in DAG, then managed availability automatically restarted that server to try to remediate it. You disable that behavior. But that's one thing that happened to lots of people with 2013 that didn't understand managed availability is all of a sudden their server was blue screening all the time. And just because it was failing one of these tests. By default, yeah. If you do get, well, I think I got the somewhere. Get health report. Get health report will get you all those parameters, and it's always running, it's always monitoring, and it's hundreds of them. So I could write something to query every single one of those things. In the old days, we used to do WMI perf counters and be like, okay, maybe this is right, maybe this is not. But again, why reinvent the wheel? Microsoft engineers already wrote something that monitors everything. So one of the nice things about our monitoring platform, and one of the reasons we selected it, was that it lets us, doesn't have to be PowerShell, they can write in Python, they can write whatever, but basically all you have to do is return an XML back as output, this XML format for the sensor. Basically it says, here's the sensor, here's the channel, here's what the maximum should be if it's an alert, and here's the current value. It's just sort of an easy XML format. And here's where you see me building the XML format right there. But long story short being is that this script, if you look over here on the right, that's how long the script is. It's not very long. The script is maybe 100 lines, and the vast majority of that is like sanity checking, formatting. The actual work is just this line, and then these lines to format it, and then output the XML. So it's really only about this long. And the result of that is this. It automatically goes out. It's every single one of those sensors that I just talked about and reports its health, as well as the total. How many are healthy? So right now, this says 95%. So this guy, mailbox space was having an issue. The Outlook proxy was having an issue. Outlook Mappy HTTP proxy was having an issue. The OAuth protocol was having an issue. This is all stuff they had no idea that they didn't even know about. If you go in there, you drill into them.
So this stuff back
yes, this is our monitoring pool, and I'll show it to you live once we get the demo stuff. But again, this is all stuff that you can get just with PowerShell and export to a CSV, or use one of the mini PowerShell health check programs out there. A lot of them interface with this. Any of those PowerShell health check scripts you find online generally interface with this. But just a simple example is that small bit of PowerShell gave us this immense capability. We have customers who, our competitors would be like, yeah, we monitor the Exchange service. And so we'd go in and like, we monitor this. And we didn't, and this took me maybe, 3 hours to write and test and then get it committed into our code base. And now it just shows up as a sensor. And it detects, it looks for Exchange service, looks for the installed registry key. And when our monitoring system detects that it's an Exchange server, it just automatically adds the test. And now if this triggers, opens a ticket, gets assigned to the resolver group goes in, sees those things. When they fix it, they can't close the ticket until the test works again. There are some exceptions when tests are broken. For the most part, they the supervisor for that. Basically, they go in, they fix it, but then when they fix it, then this goes back to OK. The ticket automatically, I'll show this as the next part, the ticket automatically gets updated saying PRTG has reported that this is now OK, and now they can close the ticket. And so using that same kind of test-driven development, taking that beyond just code and taking it into infrastructure has really sort of revolutionized our business, because we don't need a guy going in there doing this kind of stuff. A lot of these things for certain triggers like services, it just goes in there and tries to restart the service a couple times before it comes up. If the customer has an SOP where they're like, oh, this happened, they have a batch process and files get stuck in it. Oh, well, we just need you to move those files to another place and restart it. Right? A PowerShell script for that, attach it to the sensor, and when that thing trips, it automatically goes out to the server, does that process, and now this thing that these guys were getting woken up at 3 a.m., every other day for, is now fixed, and they never worry about it anymore. And the value that's, again, being a revenue-generating organization on our side, demonstrating that value and being worth our money is huge for us. And most importantly, we write it once. This sensor now, there's now hopefully like at least 1,300 of these in our system now, because it now found every Exchange server across our entire organization and started adding this. So here's a bit larger example, and we'll do the demo. I pray to the demo gods. So in this case, we have our PRTG function. So here's a very simple view of an Azure Functions in VS Code. You normally wouldn't see it this way. I'm showing it this way because you can control through revision control. This is a view of some of our ticketing system stuff. So this right here, the submit and the update. These are the key pieces of code here. It's going to be kind of small. I'm going to get this into Zen mode real quick. So the script, again, the script is what? It is 100 lines long. Again, this piece of code here, this takes every single ticket that comes out of our PRTG system, converts it to the format that our in-house ticketing system called Auditats uses, and submits the ticket in there. This whole piece of code processes, hundreds of thousands of tickets. This is it. Well,
Could you write it longer?
Yeah, just to mess with it. I mean, I could make it shorter, but. And that's, I like to do the opposite. I like to show the beauty and simplicity because it lowers the barriers to entry. To show people that you can do this kind of stuff with just a small bit of code, people are like, okay, I'm now interested in this. Most of the barriers of people is like, okay, like the C# guys will come back and say, well, we got to write a class, and we got to write constructors, and we got to do the interfaces, and it's going to be a 2-week project. And they're like, well, I just wrote it right here. And again, and the great thing too is that you don't really have to be. Some stuff I write will look really convoluted. And I always add a comment when I do, especially with like regexes. Whenever I write a regex, I always explain what the regex does, because even I have no idea what that thing does when I come back to it. If you ever work with regular expressions, which are text matching, if you've ever done really fancy text matching, regexstorm.net, recommend that. Because it's a real-time regex parser for .NET. Most of the ones you'll find online will do Perl. This is one that'll do it for .NET, which is what PowerShell uses. And basically, you can write a regex and put in text, and it will in real time show you what it's matching. So you can edit it, change it, and every time you change it, it shows you exactly what it's matching and what the outputs are. I write all my regexes in that. Super helpful. I wish I had a plug-in to VS Code that did that, but I can't find it. So for now, it's just that website. By the way, this is, if you haven't ever seen this before, this is Visual Studio Code. This is free software. You can go out and download it. This is now the PowerShell team's de facto PowerShell environment. They're no longer developing ISC. I love ISC, still use it all the time. I have to remote to a server and do something. But these days, I do everything in code. It was a bit of a process to get over here. I was doing this in the very early days when the extension wasn't all the way there. The extension is about 90% of the way there. The big problem right now is that the integrated console doesn't feel PowerShell because it doesn't support this thing called PS readline, which does all the history stuff and all that, and the tab completion, all that stuff. So the problem is that it's a really hard problem to solve because of the way that a couple pieces are done. They're working on it. They're almost there. And once they fix that, then this is going to be definitely the premier way. But the really nice thing about this is all the real-time debugging. Again, the big thing for us is because we do everything in Git, all the Git stuff's built in here. And a plugin that I highly recommend in addition is this plugin called Git Lens. This lets you do really nice deep dives into all the info about your Git environment, like doing blames and such and all that stuff. If you're not using Git Lens and you do sort of Git or source control environment, highly recommend it. So let's go back over to my Azure and let's see if it's timed out. Yeah, I figured it would. Refresh these real quick. So on a side note, some of the DSC stuff I was talking about, here's my test environment. So you know how that guy a couple weeks ago was showing with Azure Automation? So here's how we do it with our nodes. So for each individual node, we have a DSC which we've written, which is just certain tests. This guy's not compliant on purpose because I purposely broke him. I updated his Git repository, and every pro, one of their DSC tests is their Git up to date that we use for our custom sensors, and so that's updated if not. And so down here you can see, checks this registry, checks that this remote file is present, checks for a package. We use Chocolatey. I don't know if you're familiar with Chocolatey, but basically Chocolatey is a way of installing. If you ever use like Ninite or something like that to install software, Chocolatey is like a way to do it in PowerShell, at the command line, but also to do it in PowerShell. It's really powerful, really effective. We have our own internal one for all of our internal software, and it's a super easy way to just lay down software in an automated way. When you're cheap like us, we're not paying for SCCM for all these probes. Screw that. We're going to do it for free using this. Custom scripts that we run, and then things like our Chocolatey package install. So that's DSC in a nutshell, at least doing it through Azure Automation. And the great thing about it is that if you do it against systems in Azure, it's free. If you do it against systems on-premise, if you cut down, by default it checks like every 15 minutes. If you cut it down to once a day, it only costs like 15 cents a node per month. It costs like nothing. And you get all this benefit. As long as you don't need to check them like every 15 minutes, which we don't. So there's my overview portal. You can see some stuff like this is for one of our monitoring systems. We got all the fancy stuff built in, like the memory usage, our real-time costing, so I can make sure nobody built something and ran up our bill. But here's the thing: is like huge portion of our PRTG environment, $276 a month in Azure. That's all it costs us. That used to cost us tens of thousands of dollars a month in data center space and hardware and everything. It costs us $300 a month in Azure. If I break this down, you'll notice, see these slivers here? None of these slivers are Azure Functions PowerShell, where I'll show you we run those 10,000 things. That costs us about 13 cents a month for, like I said, tens, hundreds of thousands of transactions. So I'm going to go to that function right here. Let's see, overview. Let me see if I can bring up I'll just bring up one of the functions directly, just so I can show you that same code. But basically, as I have where you saw here in VS Code, where I have it here, when I hit commit by going over here, typing a comment, hitting commit, or just hitting Control-Shift-Enter, once it syncs, goes out to our VSTS code repository, like I said, and then passes all the pester tests, and then automatically gets integrated here into Azure Functions, because Azure Functions has direct integration with VSTS and GitHub. So when our functions get pushed out here, and it takes a second to load because it's Azure. And all this has a PowerShell interface. I could show you the same spots, but I'll show you this submit PRTG ticket. So same thing. You notice it'll say, you may not be able to read this, but it says it's in read-only mode. That just is because we have it set so that nobody edits these directly. I know that might be a little small, but just trust me that that's the exact same code I just showed you over here. So that is this. You can see the same text. So here it is out here, and you can even view it as a test. You can have this set. We have our test code here. That this is basically when our ticketing system submits something, it submits it using this code. And we'll see how good the demo gods are. Okay, good. So here, this is just one. I just ran that ticket using this test code, which is basically what our PRTG submits. And it just submits a JSON file that says, here's all the parameters, here's the device, here's the sensor that failed, here's the priority of the sensor. So we differentiate, some little service from the ping, which is like the thing can't be reachable at all. We differentiate those. So some things get automatically classified as priority 1. All hands on deck incidences, where other things are like, yeah, he'll get to it in 2 to 4 hours kind of thing. And you can see some of the monitoring. This is all just PowerShell, me just doing regular PowerShell output, where I said, actually, another ticket just got submitted while I was doing this, and that's what showed up there. But here's the output. This is what it sends back to the program. It just says, yep, I created a ticket, that IN-001, that's our ticket reference. And if I were to go into our ticketing system, you'd see that ticket. I think I have the ticketing system still up. Nope, it logged me out too. I might have to browse here a bit to get to where I want. So yeah, this is PRTG that I'm going to show you here. This is just, we went through, we hacked all the CSS and everything and branded it, so it looks like our stuff. It's just PRTG on the background. If you ever use PRTG, this should look very familiar. This is one of my dev environments, so the trial license is there. So any one of these sensors, I'll show you an example again of that Exchange sensor or a similar one. It's a 2010 server, so it's not going to have it. But this services sensor. So this is all the Windows services. Well, part of our problem was PRTG would detect all the Windows services, but it would detect like a bunch of services that were either running or manual start, or were services that we didn't care about, like the print spooler. Well, not print spooler is a bad example, but things like, I don't know, like I'm spacing on one, but like one of the UI type services that we don't care about. So we wrote a PowerShell that automatically goes out to the server. And again, this is just another sort of short PowerShells. This gets every server on the service that's in automatic state and needs to be running. And then it has a summary up there at the top for the important services. If one fails, it triggers a ticket. The way that the operators have to fix that is it will go in and first try to restart the service. It'll try it 3 times over 5 minutes. And if all that fails, then it goes to an operator. Operator picks up the ticket. And a lot of times this happens when we first onboard customers. We're like, oh, there's a service that's running, or it's flaky, or it's manual. So either they restart the service. If they can't fix it, and that's something that the customer doesn't care about, if they set it to manual, in the past, they would then have to call the tools team, tell the tools team, hey, can you remove this service from the thing? Now, if they set it to manual or disabled and hit apply, the next time this sensor runs that PowerShell script, I just have a select where it's like select where type is automatic. So if it comes back the next time and that sensor's not automatic, it just drops out of this report, and now it's okay again. So again, those things of automating the process and allowing for the acknowledgments, again, just automating with PowerShell, things that guys were doing before, but they were doing it manually. Every one of those 5 minutes where they're calling up the guy or sending him the email and then waiting for the email response adds up in money and ultimately affects our bottom line. So I'll show here real quick. Let's see how we do. Oh man, I went way over my time. I'm sorry. I'll just show one of these. Well, the ticket integration I can show later, but basically it's just sending it a JSON file, as I said, and here it is. So with this, there's the slots functionality I was telling you about before. So whenever something gets committed to development or to master, it shows up here. And this is the exact same, it's the exact same functions, maybe slightly different. Right now it's the exact same because we haven't done a commit lately. But it's the exact same functions, but the environment variables are different. So if you call these APIs, and every one of these Azure functions just has a URL associated with it. I'm not going to show it because I'm just going to take it and run with it, but I have to regenerate my API keys for my test environment, but it's not a big deal. But basically, there's a button up here where you say get function URL. It'll pop up a URL with the API key built right in that you can just take that, paste it in, and then call that function. So one thing I might do a demo on sometimes, I wrote a module for getting HP enterprise warranties for HP servers. And so there's a URL I can give you that's just that you can just go to, That's hpwarranty.digital.net/HP server warranty / and then you just enter the serial number, and it'll come back with a JSON file. It'll go in, query HP's API, come back and give you a JSON file that shows when that server expires, what service contracts are covered under it. Yeah. And so that, again, there's a PRTG test that checks how long until this server expires on its warranty. So all of our HP servers across our entire customer base is constantly pulling HP once a day for all those servers, like what's the date that these contracts expire. And so once it gets to within 90 days, that kicks off a workflow that goes to our sales team, and they just get a report that they can go right to the customer without having to ask them and say, hey, by the way, your HP servers expire in 90 days. Here's a quote to renew that. Just sign this paper and you're good to go. Smooths out the sales cycle, increases margins, reduces overhead. I mean, that's what I focus on, and that's what's made me successful. Is I love the technology, but how I can apply the technology to make the business better, that's why my bosses love me. All right, so that's Azure Functions in a nutshell, and I'll show you back on the monitoring page here. So Azure Functions PowerShell can integrate with Insight Analytics. This costs me about $2.30 a month for the amount of data I send into it. But I get a full view of all of my data, every single execution. I can drill into this for every single execution, see the average response time, how many server requests, how much Azure is fanning this out. Because Azure Functions, you know, if I submit 10,000 requests to it, it just spins on the back end. It just spins up a bunch more virtual machines to run my PowerShell code on. And then when it's done, it shrinks it back down. I didn't write that. I only know how that works because they open source how the code works. But I didn't write any of that. All I wrote was that. All I wrote was that code that I saw when you hit run. And then I published the URL. And I don't have to worry about the scaling of it. That's the promise of serverless computing. I don't have to worry about the servers. I don't have to worry about the infrastructure. And that scares me because that's the stuff I used to like to work on. And now I'm out of a job. So I know in 10 years, I got to do something else. So that's why I'm moving towards this kind of stuff. Because, you know, it's going to take a lot of companies to get there, but it's really powerful. And so each one of these executions, like I think I have a monitor on one of these guys. Let me see if I can pull up one of the production functions real quick. Actually, one of the test functions will have it too, because everything gets submitted to them both. But just on the submit, let's see, what's the last 30 days? So yeah, last 30 days, 39,255, 1350 errors. Most of the time, these errors are just because somebody hasn't onboarded the device into our ticketing system yet, or there's like a delay between when they get onboarded. And the team goes, again, but they got all perfectly reported here, scooped up. All of that power from me just writing that PowerShell script here. So that's why I like Azure Functions. I don't have to know how any of that works. They just do it for me. And then they don't charge me anything for it, which is insane. So getting back to the slide deck. So now that you know how it's done, don't do it. Don't use Azure Functions PowerShell in production unless you know what you're doing. Here's why. It's experimental right now. Yeah, the Azure Functions version 1 PowerShell is in experimental mode. The only reason we use it so extensively is because it's open source. You can go out on GitHub and see exactly how it's implemented. We even talked to the developer who implemented it. Basically, what they do is, you know, the way Azure Functions works is it uses the stuff that runs all the websites called Azure App Service, and then it uses this thing called Azure Web Jobs, which is built on top of Azure App Service. And so that's what does all the scheduling work. And so they just wrote an extra piece in there. When you select PowerShell from a list and specify that spins up PowerShell, runs the script, and dumps the output, but uses all that same engine, all that stuff that's for much larger C#, ASP.NET, really big stuff. They just kind of bolted on this little PowerShell piece. So it's experimental, completely not supported. You can't call Microsoft for support. You can open an issue on GitHub, but that's it. And in the version 2 of the runtime that they've written, they have not included PowerShell support yet. And it's mostly because the PowerShell team is working with them to develop a new interface for it that hopefully will be better than the kind of bolt-on that's now. There's a lot of problems with it in terms of output and such like that, but we worked around all that. So we know all that. We know how to work around it. We have things on standby that if that were to ever go down, it immediately will cut over. Just again, those hybrid runbook workers that I showed in the data centers, those can take over everything that those Azure Functions are doing. But, so we know how that works. We're willing to accept the risk because of the massive benefits and massive scale that we've gotten. But if you don't do it. Don't say, I said, this is the greatest thing sliced bread until Microsoft, until you've invested hundreds of thousands of dollars in development, and then Microsoft comes to you and says, oh, we're sunsetting this in a year. It was only experimental, sorry. or you do something and it breaks and it's something on their back end and you can't figure it out, but you can't call them. They'll say, oh, that was an experimental language. We're not going to help you. Sorry. So that's my summary. In short, there's tools out. PowerShell is an amazing tool that I've used for like the last 10 years, just on the side. And it's only very recently that I've found the ability to really make it a huge part of my work life. And the things that we've been able to do with it, and the culture that we've been able to drive to really expand it, everywhere, anything that we can find, we can write a module for. I mean, a future thing I can do is the different modules I've written for. Programs that had APIs but they didn't have PowerShell modules, I wrote a PowerShell module for it. It really wasn't that hard. And there's a way to actually generate PowerShell modules from REST APIs called PS Swagger, which we can talk about in a bit. But in short, that's how we do it at Allied Digital. That's how we handle some of these problems at scale. And most importantly, how we do it at scale, being cheap bastards. How we do it as cheaply as we can, but being able to leverage all the things that we would want from a commercial system. All the auditing, all the tracking. I mean, you saw those metrics that I have that I just get for free. And then we have Power BI reports that give us our monthly summaries. And for all of our customers, and the analytics are there. So that's my shtick. Thanks for sticking around. If you guys have any questions, I'm going to go ahead and drop this back into demo mode. And if there's anything you want to see, we can go through it. So thank you. And thank you to everybody out there.
Any questions?
Yeah. But the nice thing about a lot of this is we don't believe in we don't believe in reinventing the wheel, and so a lot of this, we like to stand on the shoulders of giants. So everything with the Azure stuff, that's all. If you go on the Azure Web Jobs SDK, I think is the GitHub name, you can see exactly how PowerShell works on Azure Functions. And if you were to start a new one, let me see if I can switch over to my. Do I have my guest? Let me switch over to my Azure Test instance here. I'll just show you how to start one up. It's doing pretty good for tethering off my cell phone.
Yeah.
T-Mobile is awesome in this town. Everywhere I go, I've got like 30 down, 30 up, minimum. All right, so here's an example of just like a test function. Again, you see all these pieces, app service, etc. Again, functions just runs on top of app service. But it has that consumption thing, and they give you 2 million gigabyte seconds per month free to use. Which maybe that'll go up in price in the future, but so here I am, going to make a new Azure function. I got different options here. I can do a timer, where like this is normally what you would do in Agile Automation. I want this thing to run every 5 minutes. We do this for our governance scripts. Every 5 minutes, check our PRTG, look for sensors that had an unexpected result and report on those. Or look for servers that have been down for 5 minutes, but nobody has done anything about it. We have a bunch of governance checks, so make sure balls don't get dropped. Data processing. Now, there's these things called queuing and such that you can do that I'm not going to get too much into, but the queuing stuff is like you can have things where like this thing collects it and then drops it into an Azure queue, and the other script, all it does is watch the Azure queue and then pick that up. Building those kind of pipelines, they're really great for APIs and stuff. You want to get really fancy with it. If you've done any Lambda stuff or anything like that, you know all about it. So here we go. And so here's what I'm talking about. If you want to do anything in PowerShell, you have to go up here, experimental language, and turn this on. So you can't say, oh, I didn't know, because you have to turn that friggin' checkbox on to do it. Now again, and you can also, all this you can do in PowerShell. You can do new-Azure function, build it that way.
Do they have a estimate when they come out of?
So the version 1, basically, they literally just like wrote the same thing they do with Python. Like if you look at the code, they literally just wrote something that says, if it's a PowerShell script, call PowerShell, return the results, and do it. But it uses all the same infrastructure. But it's kind of a hack job basically. But it works and it scales, and we did a lot of testing with it, and the code base isn't changing, so we're fine with it. The version 2 stuff, no, I haven't heard from. They keep that stuff close to the vest, so we don't have a roadmap on it for when it's going to be really fancy. We just go PowerShell, and then I can make my new function. I can call this my test function. And then you have this thing for the authorization level. This is just basically, do you want it to be an anonymous function? I'll make this anonymous. This way you just don't have to have an API key to access it. And you can front end all this stuff with Azure API Gateway, which will let you do like OAuth authentication and stuff. So if you want to tie running certain Azure functions, like you have to log in using a Azure AV login, you can do that. It doesn't just have to be API keys and stuff. And put limits and all that crap. So I did new, and here's my new function. I don't know if I can blow this up. I can try to blow it up a little bit. Yeah, Azure tabs are terrible for presentations because they cover so much space. So this is basically a real simple function that they include in the beginning. Where basically what it does is it gets the content and converts it, gets the request name, and then outputs it. So if you look here at the test, this is what it's doing. It's doing a post, and it's posting this JSON where name equals Azure. So what do you think is going to happen where it's name equals Azure, outfile whatever name was, what do you think is going to come out? Right, hit run. You see it starting over here. There's the, you can see the logs over there. Hello Azure, there it is. It's also set hello up there. So now that I have this, I can go up here. I can take my little get function URL button here, and there it is. I can take this, and if you want to, if you've got your computer, you can put this into your computer right now and it'll work. Here's the hello. Now, where's the Azure? Well, I didn't provide it as a parameter. Oops, I didn't like that. Azure goes. How did you think that I was Googling that? There we go. So see how I provided the parameter? It just brought it through? Oh, yeah. So that's the really nice thing about this is using it for web APIs is because when our ticketing system calls it, in our ticketing system, all we have written here is, where are you? This guy. So I'll show you the integration for notification. This is the test one. So here's an instance for our prod integration. So all we did was tell PRTG. PRTG doesn't understand PowerShell. It doesn't understand any of this crap. I mean, from the notification standpoint. So we just told it submit this Azure function. I get down here. Execute HTTP action. Just go to a web address, which is this address with the partial API code. Can't do it the rest of it, so you won't see all of it. And then you have these different all these parameters in the JSON. So we've made JSON that says for each of these things, the little percent thing is a placeholder in PRTG where it'll substitute that thing. So the group, the node name, the week probe, the uptime, the device status, the group state sense, etc. So it just basically sends everything, and then our script just parses out the things that it needs, converts it to a ticket, and sends it on its merry way. I mean, that's how our ticketing integration works. That's all we have to do. And so now the tens of thousands and other systems work similarly. So we also use Kaseya Traverse, which we're trying to get away from because there's strong arming us on the licensing. We use SCCM for a couple customers because they part of our contracts that we had to, et cetera. But basically, when we have our one ticketing system, so one way or the other, we take those integrations, bring them in through Azure Functions PowerShell, and run it down. And we don't have to worry about it because we know it's there. We know it's highly available. We know it's redundant across regions in Azure. We know it's scalable practically infinitely. We've run, I think our peak we run through it was like 5,000 tickets a second, and the response time only went up to like 200 milliseconds. It just fanned out. You can watch it, like we have another graph. You can watch it where it's Microsoft is on the back end spinning up extra virtual machines to do our thing. It gets up to like 15, 20 virtual machines, but we paid the same. Then again, with 2 million gigabyte, the way they do the metrics is it's how much memory you use per second. So if your PowerShell script is currently using 500 megabytes for a second, that's 0.5 gigabit seconds. If it's using 2 gigabits of memory per second, that's 2 gigabit seconds. You get 2 million gigabit seconds free per month. So that's one PowerShell script that you've consumed a gigabyte of memory running for 2 million seconds. It's a lot. So if you take that, huh? Yeah, exactly. Well, I mean, here's the thing: is like we write these lean, and mean. Like it's cutting down that time as much as we can. Anything that we can do to avoid any kind of timeout, any kind of parallel processing that we can do to fan the thing out to get it to end as fast as possible. That's what we do. so we use all kinds of things like Posh RS jobs. This is one of my favorite modules. If you ever use PowerShell jobs, use Posh RS jobs instead, because that does the same thing as PowerShell jobs, but it uses PowerShell run spaces, and it's infinitely more efficient. Yeah, Posh RS jobs. I mean, you can do run spaces manually. All that is a wrapper around doing run spaces, but it's extremely well written by a Rambling Cookie Monster, and covers that stuff really well. All right, well, thank you, guys.
No, so, yeah. Thank you, Justin, for a great presentation. We've got good feedback from the folks online. Really enjoyed your presentations. And for the couple of folks on the line, thank you so much for joining today. With this, we're going to end our stream. But before we do that, a little bit of housekeeping, as I mentioned earlier in the presentation. Thank you to Sapien Technologies for providing the pizza for us, and also to Viewpoint for continuing to provide this great venue for us to hang out. So with that said, once again, thank you. We'll end the presentation now, and we'll see you next month.